Now, continuing in Chapter 1, Topic 1.8, Inverse Function. These are the objectives. Again, we'll be going over this. If you want to pause to read them. A definition of an inverse function. So, for background, let f and g be two functions such that this, for every x in the domain of g, and this, for every x in the domain of f, we say function g is the inverse, and inverse, by the way, is denoted by a special function symbol, the letter f to a -1. Now, this is not an exponent here. This is the symbol for the inverse function. And basically, it's exchanging the x value with the y value. And you'll see that illustrated as we go on. So in example 1, we have this f function and this g function. Now we're going to take this and put it where the x is here. So then that becomes the 4 and this. Now notice what happens here. The 4's cancel out, and we get x plus 7 minus x equals x. Now that's the composition of f with g. Now if we do the composition of g with f, we're going to take this function and put it where the x is up here. Let me clear that up a little. Right there. And that's what they're showing here. So -7 plus 7 is 0, and we get 4x over 4, cancels out, and we get x again. So this indicates that they are inverse functions. Now, there's another way to show this, but we'll go along with what they're showing here. Now, in this slide, they are going over the protocol for finding an inverse function. And generally, what would it be like? Well, you can pause and read this, but I'll give you an example. For this, I'll go to the whiteboard. And here's a very typical slope-intercept form. We want to find the inverse of this. And we said that step 1 was to switch the x and the y. So this is our initial function. We're now going to go x equals 2y plus 4. All we've done is switch the x and the y. X went over here, y went over there. Now we're going to solve for y. Well, I'm going to leave my y positive, so I'll leave it there like 2y. Transpose the 4, and I get x minus 4. And then now divide by 2. And I get y equals x minus 4 over 2. So this and this are the inverse. And if we had this as a function, this would be listed as the inverse function using this symbol. All right, going back, I think an example was useful there. going back, clearing this up, and that's what they're showing. All right, let's go on. Now, finding the inverse of a function. Well, would you believe they're just doing what I did here? All right, I should read ahead a little bit. So let's do example 2 again. And taking this as it comes. So again, we can replace this with a y here. 2x plus 7 going to our whiteboard. So we're going to switch the x and the y around. This becomes an x. This is 2y plus 7. We're going to solve for y, so we got 2y. X minus 7. Divide both sides by 2. And we then get y equals x minus 7 over 2 is the inverse. And now let's see it officially done here. And there you go. So the symbol for inverse, again, it's not a negative exponent, it's just the symbol for inverse is this. All right, well done there, Mr. Paulin, there, whatever. Okay, let's go on. Now, first of all, we also have another rule that we need to bring in at this time is something able to have an inverse? And we say in order to have an inverse, it must have what we call a one-to-one relationship. And that is our original must be a function. So if you recall what we were doing so far, we had y equals 2x, let's say, plus 7. Now, when we did a graph of that, our y-intercept was 7 here, and our slope was over 1 up 2. So we ended up with a line. Oh, that's not a very good line. Let's make a nice line there. I have a line tool. So something like that. Now, my question is this a function? Does it have a one-to-one relation? And for this, we're going to use what is called now the horizontal line test. Got this little yellow line here that I'm going to move down. If I can get my, yes, there we go. Move this yellow line down, horizontal, over the red line here. That's the graph of this. Now, does it intersect this in only one place at a time? Remember the vertical line test was we did it vertically. This is horizontal. And the answer is yes. So this is capable of having an inverse. We say it passes the horizontal line test. And it's very similar to the vertical line test. Okay, let's go on. And here is a nice example of the horizontal line test. Which of the following graphs represents a function that would have an inverse? Well, as that red line's coming down, it's intersecting there and there. So this would not have a function. While this nice little curve here, as the red line comes down, it's only intersecting at one part. So this B would have an inverse. Okay, something easy. Now we want to look at the graph of the inverse is a reflection of a graph about line y equals x. Now to make that graph, let me just do that quickly here. And I'll change colors here. the graph of y equals x goes right through the center and looks more or less like that. The equation of this line is y equals, remember the slope is 1x. Remember there's a 1 in front there and it's plus 0. Our y-intercept is the origin here. Now we're wondering, are the graphs that we see, are they a reflection? One being the inverse of the other. Let's clear that up and go on. So there's one set. Is this the inverse of the other? And the proof of the pudding is we put them both on the same graph. And what do you note then about our equation, y equals x? That if we folded along this particular line here, the graph, one would be on top of the other. That would be the reflection of a graph about the line y equals x. Okay, again, short lesson. You're picking up on vocabulary, and I'm repeating that often. And of course, knowledge and symbols, and of course, proof of the pudding, so to speak, is you're doing your homework and then doing well on your test. All right, we'll wrap this up.